Okay, so welcome back. This is the second part of our free movement vectors lesson, which is based on lesson 5 of my GitHub. So if you go to my Pygame template repository on my GitHub, you'll find lesson 5 there. In the last tutorial, we made it so that the enemy would start moving towards our spaceship. What we want to do in this tutorial is make it so that our spaceship can actually rotate and face our enemy. And I've avoided doing rotation up until now because the code's a bit yuck, but it's something that I definitely think you'll be interested in doing. So just what I'd like you to do is if you can go to your spaceship sprite class, you'll notice that we actually store the original image. So we want to make sure that we actually have a copy of the original image, because every time we rotate, we actually rotate that original image and then save it as our actual image inside the sprite class. The other thing we're going to do is we're going to give it a speed limit. I prefer you put it in now rather than later. The speed limit will just cap exactly how quickly we can move. And what we're going to do is we're going to replace all our movement code. So the movement code in the last lesson, we had the sprite moving up and down, left and right, and diagonals. Now, you might still like to do that for your particular game. I mean, you could have like, you might have a Pac-Man game, or you might have some other type of grid type game. You may wish to keep that type of movement, but what I want to show you is how to establish free movement, because I know I will get that question. And it's a bit trickier, but we can definitely do it. So I want you to delete all the code that was previously inside the update function of your spaceship. And what we're going to do is we're going to separate it out. So the first thing I think we should do is let's rotate the spaceship towards the mouse. And what that means is let's put the spaceship in the middle of the screen as well. So if you can go back to main.py, go to where we start running the game, and you'll notice that we set our spaceship to be 500, and I think that was also 500. Change it to 300 so it's a bit closer to the middle of the screen. And then here we're going to create a function. So I've created a function called process mouse input, and this is going to be my own function. And then I'm going to write that function. So here I'm going to create a function called process mouse input. See, it's catching two inputs, the mouse position and the mouse buttons. And then I'm going to get the direction from myself, from my position to the mouse position. And I'm going to normalize that direction. So as I said in the last lesson, when you get the difference in terms of a horizontal and a vertical between two positions, rather than us just teleporting, we actually need to reduce the length of that. And that's called normalization. Normalization is about reducing the length of our vector to a length of 1. So that line of code will set the direction. Now I need to set the angle. So I'm going to set an angle to my direction. And the direction there's a function that Pygame has that will create the angle based on an X and a Y line, or your axes. So I've said, what is the angle to the X axis? And then at this point here, I update my image. And as I said, to update the image, you need to rotate an original image or a copy of your first image, which is why I had to store the original image. And then I set the angle, and then I've got -90 because sometimes you do need to correct by 90 degrees or 180 degrees, depending on which way the image is facing. Sometimes you just need to. The last thing you need to do is you actually need to reset the center of your image, because when you rotate an image, the center can become unaligned. So you do need to reset the center of your image. And then finally, we're going to make it so you can still shoot using a mouse button. Instead of using a space bar, we're going to shoot using a mouse button. So if the mouse button 0, which is the left button, is equal to 1, like we did before, let's check that a significant amount of time has passed before we can shoot. Otherwise, it's going to be machine gun fire. So this code here you should be familiar with, except we've triggered it with your left mouse button. So now we should be able to, I realize that I need to comment that out. Now, actually no I don't. Now let's run the game and see whether we've rotated the sprites. Right, so it's rotating the sprite now. You can see how it hasn't rotated the laser beams. The laser beams are always vertical, so let's rotate the laser beams as well. So with the laser beams, we are again going to create a copy of the original image. So this is inside my laser sprite. Copy the original image, and when the laser is automatically created, we want to, at that point, set the angle. So it's a bit different from our spaceship where it's going to keep updating every frame. Once a laser has been created, it's not going to change its rotation. So I'm going to set the angle to its direction, and the direction will be the direction it's been given that it's moving in. So I just need to set the angle. This time I'm going to plus 90. I probably could have gone subtract 90. I'm not actually sure there's much difference. And then the last thing I need to do is I need to rotate that original image again. So now when I run my game, I should now see that it is actually rotating my laser beams, hopefully. But you can see that apparently I can't move my spaceship. So let's now move our spaceship, and I'm going to move it slightly different to before. So with this one, what I'm going to do is I want to make it so that I apply like an impulse in a certain direction. So I'm going to create a function that does that. I'm also going to, inside this, I'm going to update the position. So every frame I update the position, every frame I update the center. Every frame I am going to, actually no, I'll do that later on. So simply going to update the position, update the rectangle. Now I'm going to create a function called apply impulse. And this is going to be similar to code to what we did before, but it's going to work slightly different. Again, I'm going to find the direction towards the mouse cursor, and I'm going to normalize it so it's a length of 1. And then what I'm going to do is, so that it's a bit smoother in terms of its direction, I'm actually going to set the direction to equal itself plus the direction towards the mouse divided by 2. And you're probably wondering why that would be the case. Well, what it means is that if you're moving really, really quickly in a certain direction, then simply moving towards the mouse cursor might do an abrupt stop, whereas you might want to actually kind of curve towards it a bit nicer. So what it means is that as you press key down, it doesn't just do an abrupt move, it should be starting to move towards that direction. And if you hold it down, it will definitely move towards that direction. Then we're going to add speed. So we're going to make it so you can keep getting faster and faster if you move in a certain direction based on holding down the key, which is different from what we did before. What we did before was we just moved at a certain speed, which was always 1 times by the speed that you'd given it. I think it was 4. So we're always moving at a speed of 4. This time we're going to make it so you can actually increase your speed, which would be like a racing game. A racing game, you're going to want to keep increasing its speed, which is what we call acceleration. So I'm going to do that for all my keys. So it's just slightly different to the way we did it before. Each time I'm going to change the direction slightly, and I am going to, if the speed is less than the speed limit, I'm going to add onto the speed. So it should get quicker and quicker. And then you can decide what speed limit you want to have. So I've got a speed limit of 3. I might make it 4 actually. So now I've got a speed limit of 4. Let's see what happens. So you'll see that the movement is now way different to the movement we had before. because we're now kind of putting a bit of physics into the game. So let's do that. So I'm moving physics into the game. Now you can see that I'm able to move, and if I hold down my key, I go a bit faster. Now I can still shoot. I've actually got it so that it can actually rotate around based on using So it actually goes towards the speed limit, and if I wanted it to be more of a gradual process, all I would need to do is actually change it so that rather than plus equals neg 0.2, I would make it plus equals 0.1. But you can imagine how the speed gets to a certain thing and it gradually gets faster and faster. So that's how you would actually increase your acceleration. Right, the last thing I'm going to do is I'm going to make it so that if it goes outside the actual screen, it wraps around to the other side. And that's where I'm using my own little helper function. So if you actually go to game.globals, you'll find that there is a helper function here. And I've got if sprite is outside of a rectangle, I can wrap it around to the other side that it's collided with. So I just created this. I created this script, and I'm basically just going to get the size of my screen, and then I run the script and I set wrap is equal to true. And what should happen now is when I play my game, it's now going to wrap around to the other side. So I'm going to the other side, you see that now I wrap around to the other side. Also, by the way, this kind of movement is a bit hard to play the game if you think about it. So I quite like it. But you could easily, I mean, there's no friction in space, but if you wanted to have gravity or you wanted to have friction, then all you would need to do is every frame you would actually want to decrease the speed. So if you did want to have friction, you could actually just say speed or self.speed is equal to self.speed times, I don't know, 0.9. And that's going to be friction because, I mean, like I said, there's no friction in space, but if it's moving in a certain direction, there's no impulse, then it's not going to keep adding to its speed. Instead, it's going to start taking away its speed. So this is just an example of gravity or friction. And if gravity really is just friction in the vertical direction. So you could always do that as well. And especially if you're doing like a platform game, you could do that. So let's just see what happens. Alright, I'm going to move in a certain direction. And you can see that gravity quickly decreases it. So the gravity, the friction is far too strong at the moment, far too strong. It's hard to actually beat the impulse itself. So, I mean, if you wanted to increase your impulse, you could. Maybe put that, maybe make it so it's 9.95, maybe increase the impulse to 0.3. And you get the idea. You can actually make it so that things slow down. But obviously in space that makes no sense. So I'm going to just, in terms of my update, I'm actually just going to comment it out. But if you were designing a platform game, what you would need to do is you would need to change the direction, have it so that the speed variable takes into account your actual vertical speed, and you'd want to add to it as it's moving down, if that makes sense. Okay, all right, I'm going to stop there. Thank you very much for listening.